So I just want to finish up this set of slides before we get into the labs, because on Moodle now I've published 2 labs in this section. There will be more though. You've got enough information to do the first lab as it is, but you won't be able to do the second lab until I complete the slides. So let's do that. So what we know is that a version control or a source control management tool is really all about keeping a history of changes that have happened to files in a project. And it allows us to kind of wind the project back to a previous stage or an individual file, or to see what changes have happened to files over time. Physically, a repository, when it's on your local hard disk, it's just a folder called the .git folder within the base folder of your project source code. And on the right, then I'm showing you what the internals of that looks like. Today, we'll dig a little bit deeper into the internals on the right-hand side. From Git's point of view, any file within your project could be in one of a number of statuses, which I think I talked about here. As far as Git is concerned, a file might be an untracked file, which simply means it has no previous knowledge of that file stored within the repository. It could be an unmodified file, which means in the repository, it's got the most up-to-date status of that particular file. Modified means that the repository is slightly out of date with regard to the status of the file on your file system. And then there's this kind of odd one called staged, which means you've told Git that you're about to commit modifications that you've made to the file, but you haven't done it yet. It'll be the next step, if you like. Also, we talked about the working directory. The working directory is essentially where you create files and edit files, all that, those kind of activities. Then we talked about when you do commit stuff to a repository, you've got to include what's called a commit message. And the commit message, although you might think it's not that significant, it is really, because it's a way of communicating to other people that may be working on the project with you as to why you made changes to files or added new files. And the emphasis is on why. So you need to sort of step back and ask yourself, well, why did I make the various edits that I've been working on for the last whatever number of hours? And then the answer to that question should be expressed in the commit message as succinctly as you can. Then where I kind of finished off the last day, we're saying you don't commit everything to a repository. Any kind of files that are generated by a tool or by the operating system, they should never be included, because they're auto-generated. They're not manually created. It's only the manually created files that we want to commit to a repository, because they're the ones that are being edited. And so the way you tell Git which files and folders it should ignore is through this special .gitignore file, okay, which you create in the base folder. And what I was saying at the end of the last day is that it's really important that you try and get that right from the outset, because if you already make commits and then you decide to create your .gitignore, it's too late, really. Now, in the gitignore file, you just have, it's a simple text file in one sense, and you express or you declare which parts of the working directory that Git should ignore when it comes to committing stuff to the repository. there are a certain amount of wildcard characters and regular expression syntax that you can use if you're familiar with regular expressions from programming. I'm just mentioning them here. I'm not going to go through them really one by one. You can read up on it yourselves in your own time. Essentially, any line that begins with a slash character means you're referring to a directory. You can use the asterisk in the normal kind of wildcard way, but there are these other kind of wildcard, or sorry, these other regular expression syntaxes that you can use as well. To be honest, I don't find myself using them that often. Here's an example of a git ignore. And so, sorry, just 1 second now. Something is appearing on my screen that I want to remove. So in this git ignore file, because the first line it begins with a slash, it means we're referring to a directory. So we're telling git ignore any files inside in this directory when you're committing to the repository. Here, again, it's probably fairly obvious. We're saying ignore any file that ends in .log, the asterisk being your wildcard character. This is saying ignore any files in the public directory. This is a kind of a peculiar one. If you begin with the exclamation mark, you're kind of telling it, don't ignore these things. Now, I've already told it, ignore everything in the public directory. But what I'm saying here is, do include any HTML files in the public directory. So they kind of work together. And this is saying, anywhere you find a file that has temp in its name, and you can drill down into any levels within the folder structure, the asterisk means go down to all subdirectories and subdirectories. And if you find any file that contains temp in its name, then ignore that as well. So that's just an example of a git ignore file. Another thing to be careful of is make sure all of these appear on the extreme left-hand side. If I tabbed this line in, for example, or put a few spaces at the beginning of the line, then it essentially ignores that line. So just be careful with that. In most cases, I give you the .git ignore, but if you've got some slightly different setup, you need to just be aware of what you put into it. Then there are various other commands. To be honest, a lot of them I don't use, mainly because VS Code has got such good support, built-in support for Git. I find myself rarely typing Git commands from the command line. I tend to use the built-in support. So here, for example, I'm talking about the git diff command, which will show you the changes that have happened to a file. And there are various kind of options that you can specify with the git diff command. On this slide here, I'm talking about the git log command, which shows you a kind of a high-level history of the repository. Now, really what I find myself doing is the following when I'm using VS Code. So here's the catalog. And if I want to get a log of all of the commits that have happened, well, the old-fashioned way would have been to do the following. Where am I here? Oh, yeah, sorry. Would have been to do, sorry now. Keyboard is frozen. I know why now, but Q, yeah. Would be to do git log. And you can page through it by hitting the space bar. So it's showing me all the commits that I've made to my repository. But I don't tend to type that command from the command line. Instead, what I do is go over here to the left-hand side and select the git activity. And then you bring up what's called the command palette. Now, you can't see what I'm doing here, but I'm using the keyboard shortcut Command Shift P. And because I've done it so often now, it's actually showing up as a command that I've used quite a lot. But if it doesn't show up in your case, if you just type git log and select the matching one that it finds. And now this is a kind of a visual representation of the commit history for this project, where I have my commit messages, who made the commit, when it was done. Now, if I click on any one of them, then down here, it's showing me what files have changed or changed in this particular commit. And furthermore, if I scroll over here, you can see when I mouse over a particular part of this kind of blue line here, if I click on it, it'll show me what changes have been made to this particular file since the previous commit. So we're talking about the catalog test file, which you're familiar with. And if I click on this, now it's showing me what changes. On the right, it's showing me the status of the file for the particular commit that I clicked on. On the left, it's showing me the status of the file before I made that commit. And if you just scroll up and down, you'll see where the changes have occurred. So, for example, it looks like I made changes here, down here, and so on. Looks like also I removed certain stuff in the, well, I didn't remove, but so either way, anyway, you're looking for these kind of highlights here as to where you added stuff or possibly removed stuff. So really, that's the kind of approach that I would take rather than using the command line. Okay. So effectively, what I was showing you there was a git diff. And if I just go back into it again, you can do a comparison, view the file content, that's the current content here. It compares the current status of the file in the working directory versus what it looked like when I did this particular commit. Anyway, you can play around with that yourselves in your own time. But that's just because VS Code has got such good integration with Git. That's the way I find myself working. I'm going to skip over those, essentially saying the same thing. Again, there's also lots of options. In a large project, you could have a very long Git commit history. So you can do things like specify, I'm only interested in Git commits after a certain date. Obviously, this is from the command line now. So, that might be useful if you're working on a large project, which you won't be before you graduate anyway. Now, I'm going to skip over the summary. That's okay. You can read through that yourselves. The last thing I want to talk about is essentially how does Git store files and folders within the repository itself, where files and folders are essentially the data associated with your project. How does it store that data eternally? And it's all about checksums or hashes. It computes hash values for each file, and it uses that hash value to essentially label the file within the repository. So everything I'm saying here is checksummed, which means it computes a checksum or a hash value before it actually stores an updated file or a new file in the repository. And it uses those hash values as file names within the repository. It doesn't use the file names that you use out in the working directory. They make sense to you, but internally within the repository, it uses these computed hash values. And of course, the whole point behind it is if it means that the hash value is somehow reflects the contents of the file and vice versa. So it's not possible to maliciously hack the contents of a particular file within the repository, because now the hash value will not match the contents of the file. So that's the rationale behind it. The particular hashing algorithm that it uses is called the SHA-1 hashing algorithm. You may come across that in the security module. I'm not sure if it's this semester or the next semester you do the security module, but this is just an algorithm, a hashing algorithm. A hash itself looks something like this. It's a 40-character string, essentially. So it's computing these hash values for us behind the scenes, Git is. And it also uses this hashing idea for directories within your working directory or subdirectories within your working directory. So it's all centered around, and this is all about ensuring the integrity of the data within your repository. And so what I'm showing you here now is when you drill down into the internals of a Git repository, and in particular, if you look at the objects folder, you'll see files that have names like this. And this is essentially a SHA-1 hash that has been computed. And if we looked at the contents of that file, and I'll show you how to do that in a second, you can't just display it in the normal sense. There's a Git command that allows you to do it. What you would find is that will actually correspond to one of the files in your working directory. Now, strictly speaking, what it does is when it computes a hash value for a file where a SHA-1 hash is 40 characters in length, what it actually does is it takes the first 2 characters in that hash value and it either creates a folder within the objects folder that has those 2 characters as its name, or that folder may already exist because there may be another file whose hash value happen to have the same first 2 characters. Either way, it either creates or uses an existing folder that has the appropriate name based on the first 2 characters, and then it actually stores the file consisting of the remaining 38 characters. If you actually counted those characters there, number of characters, you'd see that it's not actually 40, there's only 38 of them there, whereas the hash value I said on the previous slide is 40 characters in length. A SHA-1 hash is 40 characters in length. So that's what's happening internally. You won't find inside in the Git repository, you will not find files that have the same name as the files on your working directory. So you won't find a product catalog.js, for example. So everything inside in the Git repository is stored as an object. It just uses this term object in a generic sense. And there are 3 types of objects from Git's perspective: blobs, trees, and commits. A blob object corresponds to a normal file in your working directory. A tree object corresponds to a directory within your working directory. So like our test folder and our SRC folder, they would be represented as tree objects within the Git repository. A commit object then, it's kind of slightly the odd one out. A commit object is created every time you submit the git commit command. Okay, so if I go back to the previous slide, we can't tell from looking at this now, for example, we cannot tell whether this object, so this is what we would call an object in Git terminology, does this object represent a blob object or a tree object or a commit object? We can't tell from the name, but there is a way of finding out using a special Git command. And the special command is the git cat command, which we, unfortunately, now we can only use this from the command line. Our VS Code doesn't have a nice UI equivalent of it. And the git cat command we'll be using now in a few moments. So what happens when we type the git add -a command from the command line? In other words, when we stage all of the modified files or new files that we've created and we want to stage them. When you type this command, what Git does is it finds all of the files that are modified files or new files. It computes the SHA-1 hash value for each one of those files, and it creates an object inside in the objects folder for that file, and it stores the contents of the file inside in the object. So that's what I'm saying here in 1 and 2. It also creates another file called the cache or the index file, and it's in this cache or index file, essentially it keeps a record of all of the new objects that it created up here. So it actually does put new objects into the objects folder, but the objects folder is going to have lots of objects in it already from previous commits that you would have done. So in order to record what are the new objects that it has put in, then it does that in this special file called the index file. We won't ever need to go near the index file. It's just used internally. It's also referred to as the cache file or the staging area. When you do a commit, then, and we always do a commit after we've done a git add. When you do a commit, what it does is it computes the hash value for each folder that relates to one of the files that it stored up here. Okay, so it commutes a hash value essentially for what are now going to be 3 objects, commutes a hash value for them, stores those directories as 3 objects in the objects folder, but stores them under the name of the hash value that it has computed. And finally, it creates a commit object and stores that in the objects folder as well, and computes a hash value for that. So that's all. That's a bit very long-winded, but that's what's going on in English, if you like. Let's actually try and show you that actually happening. So what I've done is the following. So if I take this folder and just drag it into VS Code, so it's a very simple thing. I've got a folder that has a file called file1, and that's the contents of file1. I've got a subdirectory called dir a, and inside there's a file called file2, and that's the contents of file2. And I've also got a gitignore file. Now I've just put some entries in it, but that's okay. Now, at the moment, if I go back out to the file system, and if I go into this folder, and if I reveal hidden files, there is no .git folder, so there is no repository at the moment created for this project, this Maria project. So let's do that. In Git, there's 2 ways of creating your initial Git repository. You can do it from the command line, which would mean just typing git init from here and hit return. Alternatively, you can go over here to the left, select the source control activity, and look, it just provides a button here. It realizes there is no repository. So if you click this button, it will create the repository for you. So I'm going to do it that way. I'm going to hit button. It's now created my repository. And to prove that, if I go back out to the file system, can we see the repository? I think we can. You can see the repository. Again, there's something popping up in my screen that's blocking my view. So I'm just going to.
Yeah, we can see it.
Yeah, okay. It's just in my way. So. And if we look inside the repository, and in particular in the objects folder, currently there are no objects. These two subfolders here are just standard kind of default subfolders. We don't care about them. But there are no objects at the moment in the repository, and that makes sense because we haven't committed anything to the repository. So let's first of all do our staging. And in fact, again, using VS Code rather than the command line. And I'm in the source control activity here now. It's telling me here on the left, these are all changes that you have not committed. And in fact, they're all, it's labeled them as untracked files, which makes sense, right? Because I haven't done anything yet. So my file 1, my file 2, and my git ignore files are all untracked. So let's stage them, and I'll do it from here, really. The way you stage everything is by clicking this plus character. So now those 3 files have been staged. And I said on the slides that when you stage, carry out a staging operation, it actually puts objects into the repository for the number of files that you've staged, which in my case is 3. So there should be 3 objects in the repository. And let's check that. And indeed there are. There's this one, and this one, and this one up here. There are my 3 objects. Don't know which is which now, though. So let's just, in fact, we could try and prove it. So if I grab the, you don't need the full hash value, you just need about the first 4 or 5 characters. So if I take this one, 5728C, and I use my git cat file command, or git cat command. I've forgotten the hash already. 5728C. I forgot the command as well. That's not good.
I think it's just a hyphen you have after git.
Yep. It should be git. Cat file. Telling me it's a blob object. That would make sense. Means it's a file. And what's the actual contents of the object? It's the -p option. And it looks like it's file 1. This is the contents here. And that is the contents I showed you of file 1. So it's put 3 objects into the repository, computed their hash value, and stored them using that hash value. If I now do a commit, it's going to add some more objects, and let's just do that, I guess. The way you do a commit using VS Code is you just type your commit message up here. And just click the correct character. Now, my repository now has 1 commit in it. And if I bring up the git log, sorry now, I'm a bit clumsy today. there is the commit. Now, let's actually do it from the command line because it's actually slightly better in terms of what I want to show you. If I do a git log, this value here, that's the SHA-1 hash of the commit object that it has created. And I can prove that if I just copy that and I use my git cat file command again. Okay, it's telling me it's a commit object that would tally. And if I do the -t option in it, or the -p option, sorry, shows me the contents of that commit object. Now, what's useful here now is, apart from it telling me, who made the commit and when was it made, it's also showing me, if I can dig it out, yeah, here, it's giving me the SHA-1 hash of the tree object, which corresponds to the top directory in my folder structure. And that would be, if I go back to the, back to here, that would essentially correspond to the base folder, if you like, this guy. So my commit object is telling me where to find the tree object corresponding to the base folder. So if I follow that path, if I copy that value and keep on using my git cat file command, I know now it's going to be a tree object, so I don't need to do the -t. Here's the contents. Did I get it right? Didn't copy correctly, I'd say somehow. Let me just grab that again. Yeah, just didn't copy correctly. So what I expect, I'm looking at, I want to see the contents of this particular object. I know it's a tree object, and I know it represents the top folder or the base folder in my project structure. So in terms of content, what I would expect to find out is what files and folders are contained within the base folder. And that looks like what it's giving me over here, telling me there's a file called .gitignore. That's its hash value. There's a tree object with that hash value, and the name you gave, the corresponding directory was that. And there's also a file in the base folder called file1, that's its hash value, so on. Again, if I looked at the contents of the object that I've just highlighted now, I would expect to be told what exactly is the contents of file1. If I keep drilling down to the subdirectory, I copy that and do my git cat file again. And indeed, inside in dir1, if you remember, there was only one file called file2. And it's an ordinary file, so it's a blob object. Sorry, it's a blob object, and that's its hash value. And if I did a git cat file on that hash value, I'd expect to find the contents of file2, the current contents of file2. Right. Now let's, so I've made one commit and it's put all of those objects into the repository. Let's do some editing. Let's edit file 2, let's say. I'm going to go back to my kind of editing activity on the top left. Sorry. And I'll go into file 2. And I'll make some edits. And I'll also create a new file. New file is in the base folder, and I'll just give it so what's changed in my working directory? I've got a modified file, and I've got an untracked file. So if I do my staging, and I'll do my staging by going back to here, click the plus here to stage everything. You can stage individual bits. So if I only wanted to stage this, I would just click that plus and leave this alone, and I could do my commit, but I want to stage everything in this case. So there's my staging. Now, when you've done staging, that means 2 new objects have been added to the repository, 2 blob objects. And then we'll do our commit. And if we do a git log again now, we do it from here. Now, similarly, this is the hash value of the most recent commit. And if I copy that, now the difference between this commit and the first commit is this commit is going to have all of the stuff that the other commit had, but it's also going to have a pointer or a reference to its predecessor, its preceding commit, if you like. And that's what it means by this line here, parent. Okay, so it keeps essentially what's happening here now is we're building up a kind of network of objects within Git. So this commit object has a pointer or a reference to the previous commit object, and it also has a reference to the object that's representing the base folder of your project when you made the most recent commit. And similarly, we can take this value and use the git cat file to drill down into the kind of snapshot of the working directory that was taken when we did the commit. Are we on time? Just do a quick Command C of that. Now, obviously you can't tell, right? But I didn't make any changes to the .git ignore. So the hash value that I've highlighted just there now, that is the same hash value for the .git ignore that existed when I did the first commit. So that means that this second commit is simply pointing to the old blob object that was created earlier for this particular file, for the git ignore file, because it hasn't changed. And that makes sense. Similarly, the commit the hash value for, trying to highlight it, for file 1 is the same hash value as before because I didn't make any changes to file 1. So if you like, it's this commit, this tree object is pointing at old versions of blob objects because those objects, their corresponding file has not been modified in this current kind of commit that we're looking at. The last one then is obviously a new one. This one here is a new one because file 3 was new. The dir A, that is actually a new object because we made a change to file 2, which is down inside in dir A. And so if you change any file in a subdirectory, essentially that subdirectory has changed. So it needs to create a new tree object for that subdirectory. That's something that you would miss really, but you need to be aware of that. So there are actually 2 tree objects in my repository now, both corresponding to dir A. There are 2 of them because I've made 2 commits, but the 2 objects, tree objects, both refer to dir A, and that's because, as I said, I've made changes to essentially the contents of that directory by virtue of the fact that I've modified one of the files in that directory. Similarly, if you added a new file to a subdirectory, that would be the case. So in the second of this week's labs, I get you to essentially drill down using this git cat file command, drill down into subdirectories to find a particular blob object corresponding to a particular file. And then you've got to tell me what is the hash value of that particular blob object. So anyway, that's for the labs. So I think that's all I really want to cover in this set of slides. There's some more stuff that I need to do on Git, but that will be for next week. So I'm going to finish the lecture here, and I'll join you over in IT 119 in about 10 minutes time. Thanks.